Well, hello, everyone. Thanks for being here. I'm David Wall. I'm the Regional Sales Manager with Carell Canada, and we're here to continue to look into the exciting topic of adiabatic humidification, and in particular, in Canada, how it is now allowed in hospitals. So exciting times for us in the humidification world. I'm here with the Head of Sales for Carell North America, Pat Demetrio, and our special guest, Steve Friedman. Pat, why don't you go ahead and give us a little introduction to Steve?
Sure. Thanks, David. And yeah, you mentioned the adiabatic humidification. It's been a critical asset for hospital facilities across the U.S. ever since it's been approved. I think it was 2017, Steve, right? But we asked Steve to join us today because Steve was at the forefront of this when we went through the change in the United States. And he had one of the first buildings, the Koch building up in New York City, that adapted this technology and really kind of broke the mold of the way we used to do it in the past. So that's why we asked Steve to join us today. And I think, we have a great discussion here, just learning about the benefits of this thing. So Steve, if you want to introduce yourself.
Sure. Good morning. And Pat, thank you. David and Kane, thanks for having me on. I'm Steve Friedman. I currently am the Director of Facilities Engineering at Memorial Sloan Kettering Cancer Center in New York City. I will just say that this part of this presentation and the information is really just my opinion. It's not the opinion of the hospital, although the equipment is in the hospital. Just a small little bit about me. I've been a code committee member for ASHRAE Standard 170 since 2005, so I've been through all the cycles. I'm also currently on the FGI guidelines revision committee. So FGI and ASHRAE Standard 170 is pretty much the healthcare design Bible for the United States. So I'm happy to share my opinions, and they're not just necessarily opinions; they're really documented and well established operationally for adiabatic humidification here at the hospital. So if you wouldn't mind, Kane, maybe putting the slides up. So just briefly here, no one's going to get whited out reading this stuff. The original ASHRAE Standard 170, the first edition was 2008, and at that point, it was only steam humidification could be used. So steam, it's an expensive resource. It does work. It works very well, but it is an expensive resource. And in the first cycle, I was able to change the language into the next cycle, which was the 2013 version of ASHRAE Standard 170. And just for those who are not familiar, ASHRAE Standard 170 is the ventilation code mandate here in the United States. You're going to say something, David?
No, I was just saying, yeah, we're going through something similar in Canada, but no, you continue. It's neat how you see the levels of progression that things happen, right? Like, so 2008, 2013, is that, so it took those 5 years to get the language changed?
Well, it wasn't 5 years. We publish every 4 years for 170. So you have a 2013 version, then 17, then 21, okay, and then 25. It just so happened that was the first go. And I didn't work on that for 5 years. I only worked on it for about a year, and I worked on it with a group of people in this 170 committee from all different. The 170 committee, I should say, are not just engineers. We're owners. We are engineers, but there's infection control experts. There's vendors. There's contractors. So you have the entire pool of people. And so what's important to understand about how this new mandate came out, it was with a group of at least 30 to 40 people from all different areas of the industry. It's not just the engineers.
It's not just one person or one area pushing and driving something to get something to happen for their own purposes or their own reasons. It's everybody contributing to do the best practices of design.
Correct. So this went into play back in 2013, and Pat, you had mentioned we put this into the Koch Center. The Koch Center is an outpatient and now also an inpatient healthcare facility within our portfolio. But actually, before that, we put this adiabatic humidification in our clinical lab medicine building. And before I got this approved in the standards for code mandate for the engineers to chew on, that was a non-clinical building. So we had put the adiabatic humidification in even earlier than that. So this technology has been in our facilities for at least 9 years and fully operational. And I'll just say this, that we have literally no issues with the adiabatic humidification. It is an unbelievably simplified system, and it works so well. And we'll go on with a couple more of these slides, and I'll get into it just a little bit with you.
Yeah, maybe you can help us. That's a good point. You can help us. It's good to hear that from 9 years of success at a key facility, and maybe it'll help mitigate the fears or any sort of apprehension that Canadian engineers might have. I'll just touch on the standard, the Canadian Standards Authority. So they set the rules for humidification in hospitals in Canada. Took them a little bit to get caught up. I imagine the cold climate had something to do with it, maybe other reasons, like legionnaires or legionella, but we can get into those kinds of things perhaps later. But the standard now, so it's 317.2, has accepted it. Not all levels of adiabatic humidification, but high pressure has been accepted into hospitals. So again, it's exciting to hear from your point of view, your professional engineering experience, how it is sort of normal now in the United States, and Canada can follow suit there, right?
Yeah, and David, you just said something that's very important that most institutions worry about is the risk of Legionella. And if you look at some of the notes, like for instance, towards the bottom there, 6.6.3b talks about treated humidification water, about continuously circulating it with pumps inside the system. So there's no storage here. It is continuously circulating water, so that it does completely mitigate the risk of Legionella. I shouldn't say completely. If someone does not maintain their system properly, there's always a risk. But the way it is written here and the way it is designed, and if it's maintained that way, the risks are little to none when it comes to Legionella whatsoever. So, and this is, again, part of that group that helped us formulate this code are the infection prevention folks, and they were very, 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 very involved in this edict. So,
right. Yeah. So maybe pop up Kane, and maybe advance it one slide. It's
sure.
We popped through that earlier, and it looked really interesting stuff there. I mean, there's energy savings, etc. But Stephen, what are we looking at?
So I think you want to go in the other direction. This was an part of the OR. Yes, here you go. So again, clean steam generation. It works. It works very well. Except when you're looking at today's day and age and market, and you're looking at real estate, and especially in construction costs. Clean steam generators, they're just large, heavy vessels. They require an energy source of either natural gas. Some might even use propane. Some would even use electricity or fossil fuel. So they're large structures. They take up a lot of real estate. They're heavy. They need structural reinforcement. And here in the United States, when you put a vessel in that takes a natural gas or a fuel oil source, you need the authorities to approve this stuff too, like the fire department and anybody who's, the fire department of New York City. They're very strict and very concerned with life safety. And so when you compare clean steam generation and the adiabatic high pressure mist, it's basically a piping apparatus with a high pressure pump. And when I say high pressure pump, we're talking about a pump that you can actually plug into a duplex outlet in the wall. So the minimal energy source on this for recirculating a pump at high pressure could be less than 20 amps. The system that we have at our clinical lab medicine building it's not even hardwired. It's a pump plugged into a wall. And so if the pump ever needed to be replaced or changed, you basically unbolt the pump. And you don't need an electrician. You just pull it out the wall like you were moving a vacuum around your house, right? So, and with the adiabatic humidification, there's no utility piping, there's no fuel storage. When I had written here about a smaller physical footprint, It depends on the size of the adiabatic system. If you're putting in a very large system, it's gonna take up quite a bit of space, but it doesn't need a tremendous structural reinforcement.
Yeah, the same very large system on a clean steam generation side of things, if we're talking equal loads, it would also be as equally large, right? Or maybe even larger. So from a design point of view, in your engineering hat, it's got a significant advantage to it.
Absolutely, it is. And when you talk about installation and speed to market, I mean, this is stuff. Some of this stuff could get built off site and be brought into new construction, or it could just be built in place. And building it in place, once you're done building it, you can actually just start it up and get going. You don't have to worry about authorities coming in and getting approvals, like you said, with fire and life safety and using fuel. So water quality is another big issue. I know that's big with everybody, because nobody ever wants to be responsible for any type of pathogen risks. So the way this system works, like I explained a little bit earlier, David, is it's basically a pump that circulates water through an apparatus, and the pipe from the system into your air handlers could be as small as a 1/4-inch tube of stainless steel. You run it alongside, up the wall, along the ceiling, down the side of the air handler, and you pipe it into a grid. And it's basically a high pressure mist. And one of the biggest differences with adiabatic humidification from clean steam is the energy use. And we'll look at that in the next slide. But before we go to the next slide, you got to understand, with clean steam, you're actually heating up water, creating a steam at 212 plus degrees, right? And then you put that into your air handler, and now you've got to cool that down. So you're cooling, you're heating up with humidification, and then you have to reheat that air and cool it down, depending upon what type of delivery you're looking to your space. The adiabatic high pressure mist, here in the United States, the water is at 65, 70 degrees. So you're not changing states. So the energy, and if you want, can you pull over to the next slide? I'll just give you, this is just an example here, and I'll spare everybody the math here. But what's important is that clinical lab medicine building I was referring to earlier. I have two 120-ton, 100% outside air handlers, and I did a case study comparison. And you just look at the energy numbers and the energy consumption and the energy cost. But what's I think the big takeaway here is the bottom three, which is your energy, your annual water usage delta. You're talking just in one air handler, you're talking about 75,000 gallons of less use with adiabatic humidification. You're reducing your carbon footprint in your building, which is so big right now in the world. It's everywhere. And I would say within Canada, because it's such a cold climate, energy is expensive, and it's a colder climate than here in the United States. There's this one air handler alone with a reduction of 62,000 tons of carbon dioxide. And if you do the comparison of total energy costs, you're looking at $34,000 versus $25,000. So you're looking at a $9,000 a year savings. That's just one air handler. So that's about $75 per ton. So
right, in one air handler. So those bottom 3 points are really, really significant for one air handler. And then often they have, double digits worth of air handlers at these facilities, right? So it's significant for each hospital, and their goals for their energy savings, right? It's all been mandated now. We have from organizations like Greening Healthcare and the Canadian CHES, the Canadian Healthcare Engineering Society, I've learned over the years the goals that these hospitals have set are pretty lofty. And for us in 2030, there's really significant energy savings goals that they have. And this looks like a really, really good application or technology that can help them reach that.
Well, it certainly is. From the energy, I mean, the math is the math. You're looking right there on the screen, but your initial costs too are most of the time significantly less, right? You're talking about a large pressure vessel that you need to crane into a building, and then the structural reinforcement and the energy sources bring into it, and controls and so on, versus putting this adiabatic apparatus, and it's night and day on your first cost as well as far as physical footprint reduction. So to me, I've used these terms in a lot of my presentations, and I truly believe it. Adiabatic humidification is just a no-brainer, and it's been live in our hospital for at least now at the Koch Center, which is a 750,000 square foot ambulatory care with some inpatient program, and it's been live since 2019 or 2020. So I am unaware of any issues with the adiabatic humidification. And quite honestly, I'd be the first one to hear about it, because if it's this is my edict and my design, and our operations folks having trouble, they're going to come to me for some help with our vendors. But I'm going to knock on wood. I've not had a single issue with this stuff. So I don't. It doesn't matter to me what part of the world you're in. I don't think there's any risk of failure with adiabatic humidification at any place in the free world, quite honestly.
Good to hear. Well, let me ask you this: let's say you're a young engineer in Canada, you're looking at a healthcare facility, and you're considering this technology, right? But you've heard over the years, or it's never been approved. So of course you're going to be, you're concerned with what you're looking at. You're going to do your due diligence and look into it. How would you help that young engineer gain some confidence in using this in what, as in their mind, they're just thinking, oh, I'm in a cold climate. I have to consider things like condensation on the perimeter rooms. I have to consider things like energy savings, of course, but reheat, all of those types of things. What should maybe help a young engineer get past a couple of those hurdles?
Yeah, sure. So I guess at the same time too, you're looking at a technology that's proven at this point. And so before I came to work for the hospital, I was in design, and David, I completely understand where the engineers come from, because they're the ones at risk. It's their professional licenses and so on. But if I was going to consider this technology, I didn't have it, I would do my homework. I'd look around the country, around the United States, to see where it is in place, and I'd reach out to people for some recommendations. But I will tell you straight out right now that this technology has been in the hospital there, and there are literally no issues. I don't think there's any risk at all. I think as an engineer, you'd be doing your diligence for the owners by not only reducing first costs, but you're reducing their energy consumption over time, right? So for me in hospitals, there's always our first cost, and then there's our operational costs going forward. So the first part is it costs a lot less than clean steam generation, and the second part is the energy, as you see it up on the screen here. So I would have trouble finding any kind of downturn on this. The only thing I could think of is that maybe your operational folks who are going to be in these hospitals, once these systems go in place, they're going to need some training, and I'd imagine that's where you gentlemen come in. You guys have your staff and your field guys that would need to educate this new technology to the engineering staff. But again, there's very little moving parts, and it's a very it's not a very sophisticated system, to be quite honest.
Yeah, it's not rocket science, so to speak. It is there's minimal maintenance required. As long as the RO systems and the water systems are being taken care of, there should be little to no maintenance required. But that said, there's always training involved for controls, controllability. There's for customer confidence, those types of things. What about another thing? So in the decarb world, the decarbonization world, we're looking at things like, often with humidification, you hear everybody talk about electric humidifiers, right?
Mm-hmm.
But in hospitals, the load tend to get to the loads, the capacity required tend to get into the higher side of things. So you start looking at, in Canada at least, at gas humidification. So gas becomes a large part of these facilities. This would be a good answer for greenhouse gas reduction as well, right?
Absolutely, yeah. Here in New York City, there's a mandate now where New York City is going all electric. So we're just in the middle of a design for a new, our newest hospital now is about, it's just been reduced. So we're about 750,000 square feet of a new inpatient tower, and the building is all electric, short of the fossil fuel for the generators, which is a code mandate because you have to have a self-sustainable source in case you lose electricity. But it is an all-electric building, so your capacity increases in demand up front, but it is clean. It is very clean. And I think the cleanliness and the gas house emissions is taking a larger presence than first costs and versus going with an energy source that creates problems with the atmosphere. So I completely agree with you. Electricity is a good way to go. It's just I do have concerns for the infrastructure in New York City. It's nearly 100 years old. And
Yeah.
quite honestly, I hope when the whole city goes live, I'm hoping to be retired at that point and just be able to read it. I don't want to get that phone call. It is amazing. Not to go off topic. My daughter is a nurse in our hospital, and just about 6 months ago, we had a blip in power up the East Side corridor from Con Edison. This is the utility, and the power went out for about 5 to 10 seconds, and she calls me on my phone because she's up on one of the nursing floors. Dad, what happened? I said the utility lost power in the street. I don't care. What are you doing about that? I go, what? I said, I'm right across the street from you. I'll get up from my chair. I'll come up to your floor and I will school you like your father. Don't ever come at me. The point is, if there's an electrical power loss in New York City, the city needs to be prepared. All communities, whether inside the United States or out, you need to have enough on-site power generation to take care of your critical systems and inpatient components.
Well, I hope when you're retired, you don't have to read like any news like that in the dark, right?
I'm hoping that with the city mandating what they're doing, I'm hoping that they're looking to reinforce their understreet distribution, because you put your engineering hat on and you realize that your peak loads of electricity is typically in the summer, right? Because that's when your chillers and your cooling load is. And then the electrical distribution gets to rest a little bit, 3 or 4 months out of the year in New York. But now with electric heat and electric cooling, now your distribution grid is pretty much hot 24/7, 365. And you wonder if it could sustain that kind of loading over the years. Yeah.
Well, we're hoping to help. This technology can help when you're converting high capacity electric units to adiabatic humidifiers, as you mentioned, with just a high pressure pump with low energy requirements. Maybe let me ask you one final question from our point of view for again thinking about things like colder climates. I mean, Canada does have a wide range of climates across the country. It's a big country, right? We know anyway that the climate can change within 24 hours pretty significantly, but maybe let me ask you if you thought about, or if you had to pick an ideal application, particularly in a healthcare facility, is there any sort of perfect scenario that you would look at for using this?
Are you talking about program in healthcare?
Well, yeah, what type of maybe location facility would benefit the most from a high pressure adiabatic system?
Well, I would say if we're speaking strictly in healthcare, I don't think there's not a single square foot of space that wouldn't benefit from it. Again, it's a low maintenance, very efficient type system. You're in healthcare, your critical areas of humidification is basically in your ORs. It's your CPD, which is your central sterile processing, and definitely in spaces like burn units where you need the high levels of humidity just to make sure you heal wounds and so on. So I don't think there's any place in the healthcare sector that would not benefit from this apparatus. It's really, again, I'm only speaking because we have designed them and they are installed and they're operational. I don't I don't see the downside to this equipment at all. There is zero. I'd like to be able to do the pros and the cons, and I just can't find any on the con side of this type of system. It really works very well, and it's low maintenance, and it delivers. It absolutely delivers.
Well, thanks. It's so good to hear from somebody with professional engineering and healthcare design experience. I'm sure that somebody listening to this will benefit from it.
Yeah,
if they're sick of listening to me. It's been years since I've been trying to say that this stuff will work in Canada, and it's tough to say that when the regulations are against you, or not against you, but the regulations aren't in place yet. So now we're here. The regulations are there. CSA is on board. We have a couple of initiatives coming up that we'll talk about as well on the side here. But Stephen, I can't thank you enough for doing this. Pat, if you have anything to add, Kane, if you have anything to add, jump in. But by all means, from me, excellent to be on board here with you and this interview, and I appreciate your company.
Yeah, no, I'd just like to say thanks, Steve, for doing this. And, because your experience, you take it for granted because you do this every day. But to a lot of people out there, this is still new, right? They're still trying to uncover these things. So I think what you said here today was perfect, because it just gives them the encouragement to kind of move forward with some of these projects and be able to push a little bit where they're uncomfortable. So I really appreciate, you taking the time to share this.
Absolutely. No, it's my pleasure. And, I'm available, if anybody from up north wants to reach out, I'm happy to help them through that.
Awesome.
Again, this is no problem for me.
Yeah.
I have no reservations in answering any questions for anybody who would be interested. The colder the climate, it doesn't change the use of adiabatic humidification. The system may just get a little larger depending upon your volume of outside air that you use. But for the most part, hospitals are very smart. They will, they'll cut down to their minimum outside air in the dead of winter, just to save energy and just to be compliant with ventilation standards.
Mm-hmm.
So
right.
All right.
Well,
very
appreciate
good.
it again. Thank you so much again to everyone that's watched and hung in there with us for this interview. Again, you can reach out to Stephen if you need us. You can reach out to us. We'll all answer your questions when it comes to adiabatic humidification in Canada. Looking forward to see what this does to help hospitals get to their energy savings goals, and not just the hospitals, but also to helping energy engineers perform well in their jobs and do the right thing. Best practices is always something they talk about, so we're here to help you do that. So thanks to everyone, and
thank you.
Appreciate your time.
Thank you so much.
Thanks.
Appreciate you guys. Good to see
Thank
you.
you. Thank you, guys.
You guys.
Bye-bye.